Playing Contra was always so fun, but who knew that while playing the Contra game, their favorite Contra game, one can also have their workout. So hey guys, I welcome you all to the brand new project video in which I'm gonna explain you how I'm able to make this game. Short description about this game. I have written a Python script which just translates the body movements into a game in-game control. So for example, if in real life the person jumps, in game the character jumps. If in real life the person is running, in game the character also moves forward. So sounds pretty interesting, right? So why don't we just dive in and start coding it now. Alright, so I'll start by creating a blank directory. Let's just call this Contra game. Let's open this and create a new blank Python script. Let's just call this contra.py. Yeah, let's just open this with whatever text editor or text editor you use. So let's just open this real quick. Now let's start this. First of all, we're gonna start by importing some basic libraries which we know that we are going to use. So for example, we're going to use Mediapipe as MP, and of course CV2 for reading from the frame, and of course NumPy to work with the arrays. In future, if we need any library, we're going to import it on the way. So let's just save this. Now I'm going to write a basic code for reading a web frames directly from a webcam and showing it to the user. So it's very easy, nothing to explain in that. So I'll just quickly write that code and then explain you what is happening over there. Alright, so here is very basic code. We are just instantiating our video capture class which we're going to read from my webcam. Then in true loop, we are reading from that cap object and this returns the frame, and we are showing it to the user using this window using save2.imshow. And over here we are checking if user presses the escape key. 27 is the code for escape key. Then we're gonna release that camera resource which we are using, and then destroy all the windows which we are showing to the screen or to the user. And after that, just break out of this true loop. Let's quickly run this and see if it is running fine or not. Okay, so it says that unexpected here. Alright, so it is running fine, and now we're gonna write the main code. First of all, we will just I'll just quickly write these lines. Okay, so over here you see that we are first of all instantiating our pose object by saying pose O, and in that Mediapipe having a solution for pose detection, we're gonna use the pose detection. And this over here drawing is for showing the visuals to the user of whatever the Mediapipe is able to detect. Now we're gonna use this pose object, pose O, to process our frame. So it is going to return the result. So we're gonna say that pose O dot process, and in that it require a frame, but that frame must be in RGB format, but opencv reads in BGR format. So we're gonna use cvt color function in cv2 to convert that source to RGB format. So it is very easy, cv2.color_bgr to RGB. That's it. Now it's going to return the result, and in that result, first of all, we're gonna write a basic code or basic function which will going to check if Mediapipe is able to detect any person in the frame or not. Once Mediapipe is able to detect any person in the frame, then we're gonna continue the process of like coding the logic for running, jumping or shooting. Obviously it makes sense. So first of all, we're gonna write a script for, or I should say write basic code for checking if the user in the frame or not. Alright, so here you see that this is the image I was able to get from the Mediapipe website. Let me just open it with drawing. Alright, so over here you see that we are not going to use all of these landmark positions. We are just going to use 5 or 6 from this 16th coordinate, 15th coordinate, 23rd coordinate and 24th coordinate to code our the running logic, and 0th coordinate to code our jump logic, and again 16th and 15th coordinate for coding our shoot logic. I'm going to explain how we are going to do that, but for now you just understand that we're going to use 16, 15, 23, 24 and 0th coordinate. Now over here we just want to check if 16th, 15th, 23rd and 24th coordinate is in the frame. Then we're going to say that the user is in the frame. Start doing your further process. Otherwise, just tell the user that please make sure your full body is in the frame. Yeah, pretty easy, not much to explain it. So how to code that? Let's do that very quickly. Now you see that this result itself will going to itself can also be none. So for that, checking if the result is none or not, we're gonna write very basic line over here. If result dot pose landmark, meaning if pose landmark has something in it, it is not none, then we're gonna create another variable by the name of final result. So in that final result, we're gonna say that result dot pose landmark dot landmark. This will be the list of all these landmarks which I have showed you, all these landmarks, 32 landmarks positions. Once we are able to initialize the final result, then we will check if all those 4 landmark positions are visible in the frame or not. So now over here we will say if in frame, we will define a function in frame which will going to take final result variable, and this is going to return true if these 4 landmarks in the frame, otherwise return false. But you see that final result will only going to be created if this is satisfied. So we will also check over here if this and this, if these both are satisfied, then the user is in the frame. So let's just code this. Until now we'll just say, okay, we'll just say that print continue, otherwise else we will put the text on the screen that make sure your full body is in the frame, which is very easy. We'll just use cv2.putText function, put text on the frame, make sure full body is in the frame at this position, font will be this and color will be this, the font width will be this, the font size will be 1. Now let's define the function which is in frame. Yeah, very easy. I'll just do it very quick. So we'll define in frame function which will going to take, let's say, list. I'll call this list of all these landmark positions. Okay, so let's just reopen this. So as I said, we are going to use 24, 23, 16 and 15. Let's do for 24. So we'll say if lst of that 24th position, and it has a property called visibility. If its visibility is greater than 0.7, meaning it is visible, it is in the frame. And similarly we are going to do the same for 23rd position also, 24 and 23rd position, and similarly for 15 and 14. Over here we're gonna say return true if all of these key points or landmarks are visible, otherwise return false. Okay, so this is the main logic for in frame check if the user is in the frame or not. Let's just do one thing. Let's put the text in instead of printing statement. So we will put the text that continue. The color, let's give BGR. Let's test this real quick if is working fine or not. Let's open the terminal in the same directory and say python contra.py. Let's run this. Actually I will also do one thing. I'll use the drawing utils to draw all the landmark positions also, which is very easy. It's just one line of code. We will do, let's say, above this, after here, drawing.draw landmarks on frame. The landmark will be result.pose landmark and pose underscore connections. Let's run this once again. All right, so it is saying that make sure your full body is in the frame. Let me just stand up and try testing this now. All right, so okay, so you see that now it is saying continue. If I remove my hand, it says that make sure full body is in the frame. All right, so it is working fine. Now we will move ahead to code our run logic, shoot logic and jump logic. So I'll get rid of this line over here. Now we will code our logics, all these logics of run, shoot and jump. So let's start by coding the running logic, because that is the main and I think that is the hardest one. Then jump and shoot is very simple and straightforward. So I would recommend you to pause the video and try to imagine the situation in your mind. How would you code the run condition, run logic by using these landmark positions? So one straightforward solution I see that we will use this 16th, 15th and 24th and 23rd landmark position. We will add all 4 of these. And we will have a temporary sum and new sum. Temporary sum, or you can say that previous sum. This will hold the previous sum value and this will hold the value of new sum or new frame sum. Now we can what we can do, we can compare this, we can subtract this, and if that gets greater than some threshold value, we can say that the user has moved or is running, otherwise the user is not running. Very easy. But you know what, this is not going to work because we are just analyzing single frame, but the main conclusion can only be drawn by just analyzing I think more than 3 or 4 frames. So what can we really do? We can have a array, let's say array of 5 length. We're gonna analyze 5, 4 and 5. So first of all of these will be initialized 0, 0, 0 and 0. And now what we will do, we will have a previous sum, let's call this previous sum, and new sum. Now this array will code a function called shifting, and it is going to store the difference of both of these things, previous sum and new sum, and that will be stored in over here. And in the next phase, this particular position will be shifted over there and new sum will be stored over here. And at next time, this will be shifted over there and this will contain the new sum, and obviously this will also be shifted to the right. So after that, if we want to check if the user is running or not, we can sum all of these 5 elements. We can sum all of these 5 elements, and if the sum gets greater than some threshold value, then we can say that the user is running. Otherwise the user is still, it is not running. A lot, if you are able to get what I try to convey to you, then it is fine. Just move forward with the coding part. Otherwise I would recommend you to rewatch this particular part. If you are still not able to get, I would recommend just continue watching the code. I hope you might get what I wanted to explain to you. So first of all, what we will do, we'll create a array, or I will just give it more straightforward name. Let's give a name of sum list, and as I said, that is going to be a array. So I'm going to say np.array of initially, as I said, it will be initialized by 0.0 and it will be length of 5, and this will be something like that. Very easy, straightforward. Now for storing the previous sum, we will initialize it as 0, and for storing it, we will create a flag variable is initialized or not, for checking if previous sum is initialized or not. And also we will require a function for calculating the sum of all these 4 landmark positions, and it is going to take the list, which is the same list. Let's just define pass over here. And as I said, we will also require a function for doing the right shifting. So I'll call this function shifting, and again it will require sum, or I should say new sum position which you want to shift. Yeah, that previous sum is already global, so we are going to use it from there. And since we are going to manipulate this sum list, so we'll say, alright, so what is the task? We have to define these 2 functions, and we will first initialize, we will first just code this return sum. So it is very easy and straightforward. We'll just say return the sum of all these 4 landmarks. It will be like this: return this particular landmark position dot y position. Now y position, you know that in computer graphics, this is our x-axis and this is our y-axis, you know. So we are, if the user is running, it's obvious that user will be making movement in the y direction. It is possible that he will be making movement in the x direction also, but we are only going to use y direction because the user will be making more movements in the y direction compared to x. So we will just use y, and since this Mediapipe returns the values normalized between 0 to 1, so we will scale those values to some particular value by multiplying it by 640, since opencv reads in 640 by 480 format. Yeah, now we'll do the same for all of these other landmarks, so 23, 15 and 14. So I'll just quickly write that up. Yeah, that's it. It's going to return the sum of all these landmark positions. Okay, so we will come in over here. Now after checking if the user is in the frame or not, I'll just write it user in frame, check, done. Now after that, we will check if is initialized or not. Now if it is not initialized, obviously it is initially false. So if not initialized, we will set is init is equals to true and store the previous sum by sending the sum. What was the name? Find sum. I think I should call this find sum. I think sum is already reserved keyword, so I'll just call this find sum and find sum and pass this final result. So it is going to use this final result to calculate all of these. Pretty straightforward, nothing much to explain in. Now once it is initialized, we will go in the else part, and here we will code the run logic. Now you know that here we will after the previous sum is calculated, we will say new sum. We will calculate new sum obviously. So again we will call find sum and send this final result like this, very easy. And we will update this previous sum, obviously we will update this previous sum as new sum. So do you remember what I told you, that we are going to shift the array by just calculating the difference of both of them? So let's just code that function real quick. You know what we call that function? Shifting. So let's call this shifting by sending the new sum, and that previous sum is already global variable, so we can directly access it from there. First of all, we will have to right shift all of the elements, 5 elements of the array, so which is very easy and straightforward. I'll just directly write the code and then explain it to you. So over here you see that we are running a loop from 3 to 1 and 0. So this loop is running in reverse order, 3 2 1 0, and at 3, when it is I is 3, we are saying that fourth position will hold the sum of third position. When I is 2, we are saying that third position will hold the sum of first position. When it is 1, we are saying that first position will hold the sum of 0th position. When it is 0, we are saying that first position will hold the sum of 0th position. And then finally we will update the 0th position, since it is not updated yet. So 0th position will be, we will do the absolute of that, since the difference can be negative also. So it will be sum, new sum minus previous sum. So in this way the shifting is done. Now we will write another function which will calculate the sum of all these positions, yeah, or I will just directly call this is running or not. Initially we will just make some write some testing code to find out the threshold value. So first of all we will create a variable sm is equals to 0. So for I in sum list, we're going to say sm is equals to sm plus I, and it is going to return this sm, sum of all these positions. Yeah, now we will import the matplotlib real quick. Import matplotlib.pyplot as plt. Let's create a temporary list over here. You'll see that what I'm doing over here, I'm just trying to find out the threshold value. So you know that we are able to calculate the sum of all these landmark positions. Now it's just matter of checking if it is greater than threshold value or not. Yeah, so for finding that threshold value, what threshold value we should choose, I am writing this code, very basic code. I just created a temporary list over there, and I have imported the matplotlib to draw the graph. You will see that why we need that. Now since we have since we have done the shifting, now I will say temporary list dot append the sum, the updated sum. So it is called is running. It requires nothing to be passed in it. Okay, so once the user presses the escape key, I'll just plot all of these calculated sum. So I'll say that plt dot plot on x-axis, it will be a range of length of temporary sum, meaning just counting from 0 up to whatever value we are able to get. And on y-axis it will be obviously the temporary list, and then we'll say that plt.show. That's it. Let's try running this and see if it is able to do what I expected it to do. Alright, so it says that make sure your full body is in the frame. Let me just go back and alright, so I'll just run now and still, and again run, and again still. Now I'll press escape key to see the plots. So you see that when it is spiked up over there, then I am running, and the below part is I am not running. So we can choose the threshold value from there. So at this particular position, when y is above 40, it is running, otherwise it is not running. So let's just directly code that in the isRunning function. So you see that why I was coding that particular part. So it is no more required. So I'll just get rid of that code. Temporary dot append there, and over here instead of directly returning, I'll say if sm is greater than 40, then return true, meaning I am running, else return false, meaning I am not running. So over here I'll just make check. Here is my running check done over there. So I'll say if is running, then I'll just put text over there. I'll say running, else not running. Alright, so let's save this and quickly test this if it is running or not. The running logic is running perfectly fine. Now it is the matter of writing the jump logic and shooting logic. Very easy, you'll see that. So here we'll just first code the jump logic. So I'll define a function if is jumping. If is jump, then do the particular thing, otherwise do the other thing. So you know what, I'll just copy this. Obviously it's just same thing. So instead of is running, we'll say if is jump, and I'll say jumping and not jumping, and I'll change the position 150 and 150. Yeah, that's it. So let's just code this isJump function, which is very easy. You will see that. Now I'll define a function isJump, and obviously it is going to take that list because we want to access that final particular landmark position. So we'll pass this final result. Remember, this final result contain all the landmark positions. So let me just explain you real quick how the jump logic will work. Alright, so here you see that the zeroth, meaning the nose landmark, zero landmark, if that nose landmark goes above some threshold value, as I said, this is y-axis, yeah. So if it goes some above some particular y value, then we're gonna say that the user is jumping, otherwise the user is not jumping. So this is my x-axis, this is my 0, and at this direction the y is increasing. So I'll have to find this particular position, like what y position should I choose to make a conclusion that the player is jumping or not. So after doing some research, let me just explain that also. Let me just directly open that up. Okay, so here you see that when the user goes above this particular threshold line, then I'll say that the user is jumping, otherwise the user is not jumping. So this particular thing is y is equals to about 60. So we'll just use the 60 as our threshold value, or you know what, let's just increase it a bit. So I'll use 80. Alright, so here is the basic logic for that. So I'm accessing the 0th landmark and dot y position and multiplying, meaning scaling it from 0 to 1 up to 0 to 480. So I have scaled that up, and then I am checking if it is less than 80, then the user is jumping, otherwise the user is not jumping. So I have chosen this to be 80. So if the landmark 0th position goes less than 80, I say that jump done, otherwise not jump. Very straightforward, nothing to explain much in it. Now similarly, I'll code the running logic. So again, I will copy the same code. So now very simple and straightforward, I have to code the shooting logic. So I'll just copy the above jump logic same to same, and over here instead of isJump function we will define isShoot function, and again this is going to take the final result because I want to access the landmark positions. So here I'll say that shooting, let's make it down. Yeah, that's it. Let's define the isShoot function real quick. Define isShoot, and this takes the LST. That's it. Now we want to access this particular landmark position and this particular landmark position, and we want to check if these landmark positions are close to each other, meaning the user wants to shoot. If these particular landmark positions are away from each other, meaning the user don't want to shoot. Quickly write that code and then I'll explain it to you. Now one thing to note, that at this time we want to compare the x position of these landmark positions. Yeah, obviously it makes sense. So what we are doing is in isShoot function we are passing this list, and we are grabbing the 15th landmark position and 16th landmark position, and we are doing the difference of both of them. And if that difference is less than 80 pixels, then we are saying that return true, meaning the user want to shoot, otherwise the user don't want to shoot. So I think all of these logics are implemented now, and it's just matter of testing it a bit. So I'll just run this script and we will test if everything is working fine or not. Okay, so every single logic is running like a fluid, butter smooth, and everything is running very greatly. Now it is just matter of transferring these logics into the directly the game. So I will just wait a minute. So I am able to find out a program called FCEUX. You can install it very easily, and I am able to run this game, Contra game, directly in my Linux machine using this FCEUX program. And you see that it is like this. Okay, so you see that the game is running pretty smooth on my Linux machine, and you can if you are using Windows, you can find out your way of installing the game in Windows. And in Linux also it is very easy. You can easily find out different ways of installing the game in the machine. Now what I want to do, I will go in the options in the gamepad configuration, and in that you see that J is assigned for jump and D is assigned for moving to the right direction, meaning running, and S is assigned for shooting. So I'll just have to figure out some way of pressing these keys when the user is running, shooting or jumping, and then directly transfer those keys as the input to the game. So let me just quickly code that up. So for pressing the keys, I will use a library called Pyautogui. I'm pretty sure that you should have heard of this. So we will do what when the user is running. Let's say the D key should be pressed. Yeah, when the user is running, the D key should be pressed. So first of all, we will create a variable over here which will check is D down, or I will just directly call this D down, which will be initially false, meaning the D is not down. Similarly, is S down or not? Similarly, J down or not? So it will check these. So initially, obviously, all of these keys are not down, so we will just initialize them as false. Alright, so now we will come over here. If the user is running, we want to press that D key. Yeah, so we will check if. So if we want to run, we want to press the D key. So if the D key is not pressed, we will say Pyautogui dot key down. Which key? Obviously D key. And now since the D is down, so we will set it as true, meaning the D is already down. Now if we want to release the D key, then we will check if D is already down or not. So if D is down, then we will say that Pyautogui dot key up. Which key? Obviously D key. And now since the D key is up, we will say that D down is equal to false, meaning the D is no more down. Similarly, we will do the logic for the jump and similarly for shooting. I think I should not need to explain much in it, it is just straightforward. So I'll just replace this key down with S. If not S down will be true. Similarly for J down, if not J down. And similarly for releasing these keys, I will just copy this code and paste it over there in the else part of this. Alright, so I will change this real quick. If J is down, then key up the J key and J down will be set as false. Similarly for S. That's it. I hope after writing this code it should work pretty fine. Let me just directly open both of these, game and my Python script. Alright, let me just really quickly open the game and I'll press enter, and now I will start playing it. I think that should be enough for testing the game. It is running as it should be. And if you want to test this script, what you have to do is just download the code from the description. I will just create a GitHub link for this, and you should figure out a way to install the game in your PC. To run this Contra game in your PC, you can use this FCEUX if you want to. You can also play on your browser, like you can use the Google Chrome, and on website you can find out some websites which allow you to play the game online. There are multiple ways, and you can change the game configuration such that the D key is used to move forward, J is to jump, and S is to shoot. You can change these game configurations and you can start playing this game as I'm playing it on my PC. So I hope this should be enough for this video, since I have coded pretty much everything. I wanted to show you the running logic, the jump logic, and the shoot logic by using only these 5 or 6 landmark positions. And I would like to end this video right at this point. And if you have any queries, you can ask them in the comment section. If you enjoyed this video, make sure to give this video a thumb up, and I will catch you in the next video.